Hi Year 11s, this is Mr. Lim here again, and this is our video on column chromatography, another type of chromatography we're going to learn about. So let's get started. Alright, so we're going to learn about chromatography, column chromatography, and how it's used as a separation technique. Alright, so column chromatography is where a mixture of components is placed at the top of a tube packed with stationary phase, and then with the addition of a mobile phase, is allowed to flow through the stationary phase with the assistance of gravity. Okay, so instead of it being capillary action, which is moving the mobile phase this time, it is now gravity that's pulling down the components in the mobile phase through this packed stationary phase. Okay, so the components move through the column slowly and separate from each other in the same manner as all chromatography, dependent on the polarities of the stationary, mobile, and the components. Okay. Column chromatography is generally not used as an analytical technique because it takes too long and precise values can't be gathered, and precise values is what you need if you want to try and do any quantitative or qualitative analysis. All right, but it can be used as a separation technique, so let's go through how that works. So, used as a separation techniques, so once the mobile phase and the components are moving through the stationary phase, collection equipment can be used to collect what exits the column. Okay, so over here on this diagram, you drop in your mixture. Okay, here's your stationary phase packed in here. You pour some mobile phase in, okay, and you continue to pour mobile phase in all throughout this time. All right, what happens is that these components will start to separate as they move down, okay, and when they separate, they will take different amounts of time to go through the column, right? Once this green one, or the first one, gets to the bottom, it will start coming out, and it will come out a different color, and you'll be able to collect it over here, right? But remember, the first thing to come out will generally be the mobile phase, so that mobile phase will be coming out first, all right? After the mobile phase, the component with the most similar polarity to the mobile phase and the least similarity to the stationary phase will exit, dissolved in the mobile phase. So in this case, this is the green one, okay? And so they're using a test tube here, but you can use a beaker or whatever to collect what comes out, all right? If your separation is good, all right, which means that there's actually space between these components, all right? If the separation is no good, then the components will kind of be overlapping each other. And so like you can imagine the red one would be here, and then it would be very difficult to separate them if they were overlapped. Alternatively, you can just use a longer column, and the longer column will allow them more time to separate out and eventually become two different things, two components rather than one component, right? So if the separation is good, the component will cease to exit the column, okay? So all of the green will come out. Once all the green has come out, again, it will be just the mobile phase will be coming out of the column, and then the rest of the components will exit the column at different times. And you can just, swap out the beaker or whatever, and you can then separate the components, okay? So this is just another way to separate out things, but remember, column chromatography not used for analytical techniques. It's just used for collecting stuff, just a bit slow, good as a separation technique, not as an analytical technique. And that's it, nice and short. Adios.